Good morning, children. So, before we move on to the next question, okay, let us see a few formulae. So, number one, if you have summation n equal to 1 to n, okay, 1, then this will be equal to n because this implies that 1 plus 1 plus 1 plus n times. Okay, so that means sum will come n. So, if you see somewhere written like this, summation n equal to 1 to n, okay, and here it's written 1, then that would be equal to n. Summation n equal to 1 to n k, okay, then it will be equal to kn because k can be written k into 1, so k is a constant, so it will come out. Okay, so you are left with k times n equal to 1 to n 1. Okay, and you know that summation n equal to 1 to n 1 is given as n, so that's why this will become kn. Okay, so if you have something like this, then it will be kn. Okay, now n equal to 1, summation n equal to 1 to n, this is given by this formula. So this is nothing but 1 plus 2 plus dash till n. Okay, so this is the formula. So if you see something written like this would be this. Summation n equal to 1 to n square. That means this implies 1 square plus 2 square plus 3 square plus dash plus n square. So if you see something written like this, that is nothing but it is this. Okay, whatever you have on the right hand side. Summation n equal to 1 to n cube. Okay, so you will get this. Okay, n into n plus 1 upon 2 whole square. Okay, so summation of kn from n equal to 1 to n, okay, you will get this. K will come out as common, and this, you know what is this from here, 3, you can write whatever. Summation of kn square where n is equal to 1 till n. Okay, so k is constant, so it comes out, so you are done with this. And this, you know, it is nothing but this, n into n plus 1 into 2n plus 1 upon 6. Same goes for this. Okay, so now let us see question number 3.2. Here we have got a series 3 plus 5 plus 7 plus 9 dash 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 plus, okay, so on till n terms, and we have to show that when you add this, if you add this series, okay, if you add n terms of this series, then sum will be given by this rule. Okay, getting it? So what I have to do is, firstly I have to find how the nth term of this series, okay, how the nth term of this series is defined. By what rule is the nth term of this series is defined? Okay, so by seeing it only you can make out that here it's sum of odd numbers, okay, starting from 3. Yes, 3, 5, 7, 9. Okay, so if I want to write the second term, here second term is 5. So if I'm writing the second term, that means I will write 2 into 2 plus 1. Yes, if I'm writing the third term, then I will write 2 into 3 plus 1. Yes, if I'm writing the fourth term, then I'll write 2 into 4 plus 1. Yes, so this is the pattern. Okay, so that means I'm looking for the nth term, then nth term will be given as 2 into n plus 1. Okay, so here we observe that nth term is 2n plus 1. Okay, so then as we are supposed to find the sum of n terms of this series, so 3 plus 5 plus 7 plus 9 the nth term will be given as 2n plus 1. Okay, so there are n terms over here. Okay, so this will be equal to summation 2n plus 1. N starts from 1 and n will go till n. Okay, so once you are able to write the nth term, okay, then you have to write the nth term over here, then you have to put summation sign, and since we are adding n terms over here, so we have to start from 1 till n. Okay, now we will open the bracket for this summation, so we can write this summation as summation of 2n from n equal to 1 to n plus sign, because here is plus, then summation of 1 from n equal to 1 till up to n. Okay, Here you can see 2 is constant, so 2 will come out. Okay, then we are left with summation of n, okay, from n equal to 1 up to n. And you know that summation of 1 from n equal to 1 to n is nothing but n. Yes, so that's why this is equal to n. And summation of n from n equal to 1 to n is nothing but n into n plus 1 upon 2. Okay, and then you get plus n here. Simplify this, then you are left with n times n plus 2. Okay, so here sum of n terms for this series will be given by n into n plus 2. So suppose I want sum of first 3 terms. So in place of n, what I'll write 3. So 3 into, in bracket 3 plus 2. So 3 plus 2 will be 5, and 3 into 5, 15. You can make out 3 plus 5, 8, 8 plus 7, 15. Okay. Here question is this: find the sum of series of n terms. Okay, find the sum of series to n terms. So here this is the series. Okay, and we have to find a general formula. We have to find a general formula for sum of n terms. Okay, so in order to find the general formula, I should be knowing by what rule each terms of this series is written. Yes, before I find the general formula for the sum of these terms, I should be able to tell by what formula, by what rule each term of this series is written. Okay, so here if you try to observe the numerator, okay, like here this is the second term for this series. So here you can observe that it is second term, so it's going from 1 2. Okay, so here's in numerator you can see there is sum of cube, okay, of natural numbers, and since it is the second term, so we are taking sum till 2 only. Okay, here if you see the numerator of this third term, so here it's cube of the natural numbers, and we are going till the 3. Okay, we are going till 3 because we are in the third term. Here you can see it's numerator of the fourth term. You can see 1 cube plus 2 cube plus 3 cube plus 4 cube. Yes, so that means if I want to write the nth term, so I have to write 1 cube plus 2 cube plus da da dash plus n cube. Yes, so numerator of the nth term will be 1 cube plus 2 cube plus da da dash plus n cube. Yes, and now try to observe the denominator. Okay, so here if you see the second term, denominator is 1 plus 3. Okay, here if you observe for the third term, it is 1 plus 3 plus 5. Here for the fourth term, denominator is 1 plus 3 plus 5 plus 7. So here you can see that in denominator, okay, for this second term, 2 odd numbers are there. Okay, first 2 odd numbers are added over here. For the third term, first 3 odd numbers are added. For the fourth term, 4 first odd numbers are added. Okay, natural odd numbers are added. Okay, so with the help of this information, we can write the numerator of the nth term and denominator of the nth term. Okay, so we observe numerator of nth term is 1 cube plus 2 cube plus dash 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 n cube, and you know this is nothing but n into n plus 1 upon 2 whole square. Yes, and denominator of the nth term is 1 plus 3 plus 5 plus dash dash dash. Okay, like here you can see this is the third term, so the last term of this denominator, okay, the odd number that you are adding here, it is nothing but 2 into 3 minus 1. Okay, here 7 is nothing but 2 into 4 minus 1. Yes, so the denominator of nth term is 1 plus 3 plus 5 plus da da dash 2n minus 1. Okay, so when you add this, this can be written as summation 2n minus 1. Okay, the last term in terms of n goes from 1 up to n. Okay, now you open the bracket and you can write it in this manner: summation 2n n equal to 1 up to n minus summation n equal to 1 up to n. Okay, so this, you know, this is nothing but n, so simply n, and here 2 is constant, so 2 comes out, so you are left with this. Okay, and this is equal to this. Simplify, so you get n square. Okay, so denominator of nth term is n square and numerator of nth term is this. Okay, so therefore the nth term will be given as this, n into n plus 1 upon 2 whole square upon n square. Okay, so now we know by what rule each term of the series is written. So this is the rule, okay, by which each term is defined for this series. Now we have to find the sum of n terms of that series. Okay, so here in this n terms are there, okay, because nth term will be written this way, so this is the nth term. So from here till here n terms are there and we have to add them. So summation, and this is the nth term you write over here in terms of n, okay, and n equal to 1 till n. Now in this case you simplify this. Firstly simplify this, okay, so after simplifying you get this n square into n plus 1 whole square upon 4 into n square. Done. Okay, and you get summation n equal to 1 to n in bracket 1 by 4 into n square plus 2n plus 1. Okay, now 1 upon 4 is constant, so it comes out. Okay, now you can open the bracket and this can be written in this manner. Clear? Now summation n square n equal to 1 to n, you know what is this, so simply write here summation n equal to 1 to n. You know the value of this, right over here, you know value of this is n. Okay, further you simplify this. Okay, at the end you will get n upon 24 in bracket 2n square plus 9n plus 13. Okay, so sum of n terms of this series, of this given series, okay, will be found by this formula. Okay, this question is your homework. Find the sum of series to n terms. Okay, so this is your homework, you try by yourself. Okay, here in this case firstly you have to know how each term of this series is written, means by what rule each term of this series is written. Like this is the first term and it is 1 q. This is the second second term and it's written 3 to the power 3. Here this is the third term is written 5 to the power 3. Here this is the fourth term, it's written 7 to the power 3. Okay, but if you observe these terms are following some rules. Okay, like here this 3, this is the second term. Okay, so I can write 2 into 2 minus 1 whole cube. Yes, 2 to the 4 minus 1 cube, that means 3 cube. Okay, 2 into 3 minus 1 whole cube, so 6 minus 1 5 whole cube. 2 into 4 minus 1 whole cube, that means 7 cube. Okay, so here the nth term is nothing but 2n minus 1 whole cube. Okay, so try by yourself. Next, find the sum to n terms of the series whose nth term is this. So in this question they are saying that you have to find sum of n terms of the series whose nth term is this. So there is series, okay, and that series each term is given by this rule. Each term is given by this rule. Now you are supposed to find the sum of n terms, okay, of that series. So given that nth term is 2n minus 1 whole square. Okay, so you simplify this, so you get 4n square minus 4n plus 1. Therefore sum to n terms is given by this. You have to find the sum, okay, for n terms. So that means you have to find Sn. So it will be written as summation of an, means summation of n terms. Okay, a1 a2 a3 as an. So summation of an, where n starts from 1 and it goes up to n. Okay, so you know an is nothing but this 4n square minus 4n plus 1. So simply write this, then open this summation, okay, and you get this. These values you know, okay, simply put these values and you will get the you simplify it and at the end you will get the answer. Okay, this is homework for you. Find the sum of the series whose nth term is given by this. So you have to do same as this question. Okay, now question number 10, sum the following series to n terms. Okay, so here series is given, okay, and you have to find the sum of n terms. Okay, so before finding the sum of n terms, I should be able to know by what rule each term is written over here. Okay, I should be know by what rule each term is written, so that I can get the nth term. Yes, so here if you observe that it is 1 into 3 plus 2 into 5 plus 3 into 7 plus da 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 dash. So here this dot is multiplication. Okay, so here you can see this is 1, then it's 2, then it's 3, then it's 4, and then 5, so on. That means if I go to the nth term, it will be n into something. Yes, n into something. So let's try to observe the second number, how it's written, how the second number is written. So it is 3 plus 2 5, okay, then 7, it is like that. Okay, so it is odd. Okay, odd, then odd, then odd. Yes, so this is nothing but 2 into 1 plus 1, 2 into 1 plus 1. Okay, so let's see. Here we have, firstly we got to write the nth term. So an equal to nth term of 1 2 3 da da dash. Okay, because here you see it's actually each term consists of two parts. Okay, first part into second part. So nth term of this 1 2 3 will be, okay, into nth term of this 3 5 7. So the nth term will be like this only, nth term of 1 2 3 into nth term of 3 5 7. Clear? Now see over here, this is the first term for this 1 2 3. Okay, for this sequence 1 2 3, okay, so on. This one is the first term. Okay, so you write the first term over here. Clear? Then I want, in total this should be equal to 2. Okay, in total, okay, in total this should be equal to the second term. So what shall I put over here? Okay, what shall I put over here so that this whole thing becomes 2? So let's assume this n to be 2 over here. So 2 minus 1 into 1 plus this will give me 2. Anyway, like when we are trying to figure out the nth term, you can do it in any way. Okay, and it depends on your own logic. Okay, like how you can write them. So I can see over here that nth term for this 1 2 3 will be n only. Okay, and this second part will be written as 2n plus 1. Okay, because here this 3 can be written as 2 into 1 plus 1, this 5 can be written 2 into 2 plus 1. Okay, and this 7 can be written 2 into 3 plus 1. Okay, so these things may be a bit confusing for you. Okay, but sometimes just by seeing only you can make out what should be the nth term. So whichever way you are comfortable, okay, you just move ahead. Okay, and firstly you got to write the nth term. Clear? So I got my nth term, n into 2n plus 1. Okay, now we have to find the sum. So Sn equal to summation an, n equal to 1 to n. Okay, and n is nothing but this. So put this. Okay, now open the bracket first. Okay, so n 2n square plus n, then you can write this summation in this manner. Now 2 is constant, it comes out. Okay, and after that you know the values of this, so you simply write the values and you get simplify and you'll get the answer. Okay, this is your homework. Okay, so you please try this by yourself. So firstly you got to write the nth term. Okay, now we are coming to geometrical progression. Okay, GP. So a sequence a1 a2 a3 that is an is called a geometrical progression if each term is non-zero. Okay, so each term should be non-zero and an plus 1 upon an is equal to r. Okay, when the succeeding is divided by the preceding. Okay, for a given pair, you'll find that would be constant. Okay, and that constant is called common ratio. So constant ratio is called its common ratio. Next, in a GP, we usually denote the first term by A. Okay, the common ratio is given by R and the nth term by AN. Okay, but most of the time I write A1 only. Okay, so here I will be using A1. Okay, but in examination and all, if you see A, then that would mean the first term. And now let us see the how do we write the nth term for a GP. So A1, A2, A3, dash. Let it be in GP. Then the nth term will be given as An equal to A1. That means first term. In some books or in examination, they might simply write A. Okay, that means the first term. So An equal to A1 into R to the power n minus 1. Okay, where A1 is the first term, you can also denote A1 as A. Next, three numbers in GP are given as this: A upon R into A upon R comma A into AR, where R is the common ratio. Four numbers in JP are given as this: A upon R cube comma A upon R comma AR comma AR A into R cube. Okay, and next is you have got three numbers A and B. Okay, A and B being GP. Then this, the middle one, okay, M, is called geometric mean, and it is written as this: M equal to plus minus square root of AB. Okay, M is called geometric mean of AB. Okay, these things you can just read by yourself. Okay, now let us see the formula for sum of first n terms of a GP. So Sn equal to A1 plus A2 plus A3 plus An. So here actually we have got two formula depending on the common ratio. Okay, if your common ratio is less than 1, then you have got this formula. Okay, and if you have got common ratio are greater than 1, so in that case you have got this formula. Clear? So you have to be very careful. Okay, whenever you are being asked to find the sum, so you have to make sure that you use this formula correctly. Okay, so you have to check whether your R is less than 1 or greater than 1. So accordingly you have to use the formula. Now next is nth term of a GP from end. Okay, so this first formula here, the nth term, this nth term of GP was from beginning. Okay, now if you know the last term of the GP, you can also find n term from the end also. Okay, so n term of a GP from end is given as L upon R to the power n minus 1. Okay, so where L is the last term. Now let us see a few questions. So exercise 16.3, question 1, find 1. Question 1, find the 12th term of the sequence 1, 2, 4, 8. Okay, so here if you observe, this is not in AP first of all. 2 minus 1 is 1, 4 minus 2 is 2, 4 minus 8 minus 4 is 4. So this is not in AP. But if you observe, 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. So here you can see you are getting common ratio. Yes. So this given sequence is in GP. Okay, where the first term is 1. Okay, and R is 2. Common ratio is R. Clearly 1, 2, 4, 8 are in GP, and its common ratio is ratio R is equal to 2. So we are supposed to find the 12th term. So A12 will be A1 into R to the power 12 minus 1. Put the values, get the answer. Question number 2. The product of first three terms of a GP is this. Find the middle. Okay. So here they are saying that product of first three terms of a GP is this. Find the middle term. So we will assume, okay, we'll take three terms in GP. Okay, so let three terms in GP be A upon R comma A into R, where R is the common ratio. According to question, product of these three numbers is equal to 64 upon 27. So we get A upon R into A into AR, 64 upon 27. R and this R cancel, so we are left with A cube equal to 64 upon 27. Okay, so A is equal to 4 upon 3. Therefore, the middle term is 4 upon 3. Okay. Next is if minus 10 to m, okay, minus 10 comma 2 comma m are in GP, find the value of m. So they are saying that these three numbers are in GP. We have to find the value of m. Since these are in GP, okay, since these three are in GP, so that means 2 upon minus 10 is the common ratio, okay, and m upon 2 is also common ratio. That means 2 upon minus 10 will be equal to m upon 2. So this we got, yes. Simplify this, you get m equal to minus 2 upon 5. Okay. Question 6. Find the fourth term of the GP whose fifth term is 32 and whose eighth term is 256. So here we have to find the fourth term of the GP whose fifth and eighth term is known to us. Okay. So given fifth term is 32, but a5 means what? A1 into r to the power 4 is equal to 32, equation 1. Eighth term, A8 equal to 256 means A1 into r to the power 7 equal to 256. Yes. So we have got two equations. Okay. If you observe that, if I divide this second equation by the first one, so in that case A1 will get cancelled and I will be left with only r. Yes. So equation 2 is divided by equation 1. Okay, and we get this r cube equal to 2 to the power 8 upon 2 to the power 5. Okay, so we will get r cube equal to 2 to the power 3. Yes, so here you can see that powers are same, so bases have to be same, so r equal to 2. So we got r equal to 2. Okay, now use this r equal to 2 in any of these two equations and you can get value of a1. Okay, so I put this in equation 1, so I get a1 equal to 2. Okay, now I know a1 and I know the r, so I can find the fourth term. So fourth term will be a1 into r to the power 3. Put the values and you will get the answer. Okay, a4 equal to 16. So this is all for today.